Okay, we are going to look at our first of a series of videos about solving multi-step inequalities. When we look at these, we need to remember that this is a lot like solving a multi-step equation in almost every case. The only time it's a little different is when you have to multiply or divide by a negative number, and then we have to flip our sign, and we learned about that in the previous lesson. So we will move forward now knowing what we know and take a look at a number of different examples of these. So in this first video, we're going to look at just kind of a generic 2 to 3 step process here. And we have two different examples here that we're going to look at. So on this first one, 3x plus 15 is less than or equal to 21. We are going to remember our process as if this were 3x plus 15 equals 21. Well, what we would do in that case, and what we're going to do now, is we would say, okay, first thing I want to do is you always want to get the term with the variable in it on its own side of the equation. All right, and then you want to get the variable, the coefficient in front of the variable to be 1. So it's always basically a series of steps to isolate your variable. So let's do that. So the first thing we got to do is we got to realize that we're going to subtract 15 first. And you're going to do that first because it's a neater way to do these things. I like to think of it kind of like if you're chopping vegetables for something, or if you're cutting things up for a salad. Usually you'll like cut your lettuce up, and then you'll maybe cut up your green pepper if you put that on there. You might cut up some tomatoes, cut up some cucumbers, carrots, whatever else you're going to put on there. But you usually don't cut everything up together, right? You usually kind of like do things one at a time. And so that's kind of the same approach here, is we want to get everything kind of in their own piles. So you want to get the coefficients, or the variables kind of together. And in this case, there's only one term with variable, so we don't have much to do. And then you want to get the constants together. So get things together in their own piles. And so that's kind of what we're doing. We're subtracting 15, and when we do that, that gives us 6 over here, and then that gives us 3x up here. We're going to divide both sides by 3 now because we want to get that coefficient down to 1. And then you get x is less than or equal to 2. So let's check that. So let's pick an easy number that's less than 2. So let's do 0. So if I go 3 times 0 plus 15 is less than or equal to 21, well, that cancels that whole thing out. And then you get 15 is less than or equal to 21, which it is. So nicely done. On this next example, same thing. The term that has the variable with it is that d divided by 2 term. And so we want to get this term by itself. So in order to do that, the first thing we want to do is get the constants by themselves on the other side of the equation. So we're going to move this 1 over there by doing that. And that gives you d divided by 2 is greater than or equal to 4. And then we remember from the last lesson, to get rid of this, we recognize that d is being divided by 2, so we do the opposite. So we're going to multiply by 2. Whatever you do to one side, always do to the other side. And then just cross those out, right? Because they kind of cancel each other out. And then you get d is greater than or equal to 4 times 2 is 8. So let's try an easy number and see if this works. So let's try 10. So 10 divided by 2 minus 1 is greater than or equal to 3. Well, 10 divided by 2 is 5. 5 minus 1 is 4. Is 4 greater than or equal to 3? Yeah, it is. So we got a nice answer there. It looks good. This is, again, we haven't done anything weird yet. This is just your basic way of solving these equations. Let's look at one more really quick. All right, so let's look at this one. So this is an example of where you have the variables on either side. So all you got to remember for these is just get your variables on one side of the inequality, get your constants on the other side. I try to do it so that I get the variables on the side where they can stay positive, where they can be positive. So the way you do that is you look at which side has more, and then move the others over by that. So there's 4k over on the left side, and then there's negative 2 on the right. Well, there's more over on this side. So let's move that 2k over by adding 2k to both sides. So you get 6k plus 15 is greater than 3 because now this has gone away. And then subtract your 15 so that you can get your term with the variable by itself. So you get 6k is greater than or equal to negative 12. And then we're going to divide by 6 so that we can get that coefficient down to 1. And so you get k is greater than or equal to negative 2. So let's pick a number. Let's test this. And let's pick a number that is greater than negative 2. That's an easy number to work with. Let's use 0. So 4, we're going into the original equation now. 4 times 0 plus 15, sorry, it's not an equation, it's an inequality, is greater than negative 2 times 0 plus 3. I have 2 places where I have variables, so I got to make sure I substitute my 0 in both of those places, like that. Okay, so these go away, right? And then you get 15 is greater than or equal to 3, which is a true statement. And because of that, we can trust the reliability of our answer. So I hope this is helpful for you moving forward. The next video is going to look at dealing with situations when you have to flip the sign.